Welcome back, everyone. Before the break, I went over some definitions, but now we are going to jump straight into some examples. Let's look at the first example. So the question says, given the following quadratic number pattern, 5, -4, -19, -40. A is asking us to first determine the constant second difference of the sequence. B is asking us to determine the nth term of the pattern. And lastly, C is saying which term of the pattern will be equal to -25,939. Let's go to the first part. So A is asking me to determine the constant second difference of the sequence. But in order to get my constant second difference, I actually have to first work out what my first differences are. So if I ask myself, and I'm going to ask you at home as well, what is the difference if I'm moving from a term value of 5 to a term value of -4? You can also substitute in your D, which is T2 minus T1. -4 minus 5 will give me that the first term of the first differences is -9. Then moving on to the difference between -4 and -19. If you substitute into your D formula, you will get that there's a difference of -15. Moving on, if I want to see what the difference is between -19 and -40, I can see that there is a difference of -21 because -19 minus 21 is equal to -40. Now that I have my first differences, I can see that they are not equal, which does confirm that this is not an arithmetic sequence, but I still need to find my second differences because this is in fact a quadratic pattern. So I need to find these two differences. If I'm asking myself what is the difference between -9 and -15, I can substitute into D and hopefully everyone will agree with me, there is a difference of -6. So I've subtracted a further 6 from -9 to get to -15. Then from -15 to -21, I have subtracted a further 6. This means that my second difference is -6, and I can see that it is in fact the constant second difference. Let's move on to B. We are now asked to determine the nth term of the pattern. Just a reminder, everyone, at the beginning of the lesson, I went over the way that you find the general term of a quadratic sequence. A reminder that the nth term is Tn is equal to An squared plus Bn plus C. I'm going to write it on the board for us. So it's Tn is equal to An squared plus Bn plus C. But now we actually need to find values for A, B, and C. I'm going to be flipping through the slides so I can actually fetch certain values. But please remember that 2A is equal to my second difference. So in this case, 2A will be equal to, if I go back to the previous slide, it will be equal to -6. So if 2A is equal to -6, I can divide both sides by 2. So A will have a value of -3. In order to find the value of B, I say 3A plus B is equal to the first term of the first differences. I can immediately substitute in -3 for A because I've actually found that value. But now, in order to find B, I need the first term of the first differences, and that is -9. So I'm going to have 3 times -3 plus B is equal to -9. So this is going to be -9 plus B is equal to -9. If I carry my negative 9 from the left to the right, I will actually see that b is equal to 0. Last but not least, I need to find the value of a, and a plus b plus c is equal to the first term of the quadratic pattern. So I've already got my a value, which is negative 3. I'm going to add 0 because I know that b is equal to 0. Then in order to still find c, I need to fetch the first term, but luckily it's also on this slide. I can see that term 1 of the pattern is 5, but going back, you can see again the first term of this pattern is in fact 5. This ultimately means that if I take the negative 3 over, c will be equal to 8. At this point, please don't forget to conclude because I still need to substitute into Tn is equal to an squared plus bn plus c. So Tn will be equal to negative 3n squared plus 8. Please note that I don't have anything with bn because b has a value of 0. I hope that everyone's okay with me so far. Now that we actually have the nth term of the pattern, I can use that to solve questions regarding this quadratic pattern. Let's look at C. So we've now been asked which term of this pattern will be equal to negative 25,939. Please note that this is a Tn value because it is asking for the actual term number that matches the term value. So I'm going to be substituting in negative 25,939 n for Tn because I am solving for n. So this is going to be substituted in over there. So I'm going to have negative 25,939 is equal to negative 3n squared plus 8. I can see that it's going to be a quadratic equation because I have n squared, but I'm first going to actually carry over my negative 25,939. So it's going to be 0 is equal, oh, sorry guys, that equals looks a bit weird. Let's try that again. 0 is equal to negative 3n squared plus 25,947. At this point, I want to divide by negative 3 in the hopes that it will make my actual equation a bit easier. So I'm just going to get my calculator out. So if I say 25,947 divided by negative 3, it's going to be equal to negative 8,649. So this is going to be 0 is equal to n squared minus 8,649. Because I actually have an n squared minus an incredibly large number, I am hoping that this is dots because that will make my life a lot easier. But in order to see if it is dots, I have to see if 8,649 has a square root value, or it does have a square root value, but I want to see if it's going to be a whole number. So 8,649 gives me 93. So this is great. So it's dots. So it's going to be 0 is equal to 9, not 9 plus, n plus 93, and n minus 93. So n will be equal to negative 93, or n will be equal to 93. I'm going to stop everyone at this point. I'm going to ask if you think there's anything a bit weird or incorrect with what's on the board. Am I allowed to have a negative n value? Hopefully there's some shaking of heads. No. My term numbers have to be whole numbers because I always have term 1, term 2, term 3. They start at term 1. I don't have negative term numbers. So that means that n is equal to negative 93 is not a valid answer. So let's cross it out. Cool. So we know that it's the 93rd term of this pattern that will have a value of negative 25,939. Let's go on to the next example, everybody. So The first three terms of an arithmetic sequence are 2k minus 7, k plus 8, and 2k minus 1. We first need to calculate the 15th term of the sequence. Then we will be calculating the sum of the first 30 even terms of the sequence. So please, right now at this point, I'm hoping that the word even jumps out at you, but we'll get into it when I actually do B. But I'm first going to focus on A, which is calculating the 15th term of the sequence. Before I get into it, please remember that for an arithmetic sequence, I need to have my A value and my D value in order to find my nth term. If I have my nth term, then I can substitute in n is equal to 15 to find the value of the 15th term. Let's do the working out together. So the first three terms we know are given over here. But they are all in terms of k. So I actually don't know what the true values of A and D are. But in order to get to that point, I'm first going to solve for the value of k, because knowing what k is will allow me to determine the 15th term, because substituting k back into the first three terms will give me my A value as well as my D value. I'm going to use the main property of an arithmetic sequence in order to determine the value of k. I know that by definition, an arithmetic sequence has a common difference. So I'm going to substitute in these three values into the common difference expression to solve for k. I know that the common differences have to be equal to each other, so I am allowed to do this. So if I substitute in term 2, it's k plus 8. Then I'm going to subtract term 1, which is 2k minus 7, which is equal to term 3, which is 2k minus 1. And I'm going to subtract term 2, which is k plus 8. If I distribute the negative in on the left, I'm going to have k plus 8 minus 2k plus 7 is equal to 2k minus 1 minus k minus 8. Simplifying, I'm going to have negative k plus 15 is equal to k minus 9. Great. And then if I take my 9 across to the left-hand side, I'm going to have 24 is equal to 2k. And this means that 12 is the value of k. Great, so now that I know what k is, I can substitute that in to my first three terms to actually find the values of them. So 2 times 12 is 24. 24 minus 7 will give me a first value of 17. 12 plus 8 will give me a next term value of 20. And then 2 times 12 minus 1 gives me a term 3 value of 23. So in this case, I can see that A is 17, and the common difference is positive 3, because each of these terms increase by 3 as the terms go on. Now I can substitute into my actual formula to determine the value of the 15th term. So Tn is equal to A plus n minus 1 d. So term 15 will be equal to 17 plus n minus 1, so it's going to be 14 times my common difference, which is 3. I'm going to plug this all into my calculator. So it's going to be 17 plus 14 times 3 is equal to 59. Great. And then the last question, everyone, is to determine the sum of the first 30 even terms of this sequence. The sequence goes 17, 20, 23, 26. But I've been asked for the sum of the first few even terms. The even terms of the sequence are 20, 26, and 32, because this is term 2, term 4, and term 6. These are the even terms of the sequence. I still need to calculate the sum of the first 30 even terms. So because these are my first three terms of the even sequence, I have to find a new A and a new D. So my new A is 20, and my new common difference is 6. Then I'm going to substitute this all into the arithmetic series formula. So the sum of the first 30 terms will be equal to 30 over 2 times 2 times A, which is 20, plus 29 because it's n minus 1, times 6. Let's pop this all into my calculator. So I've got 30 over 2 times 40 plus 29 times 6, which is equal to 3,210.